This is the second part of time value of money. This slide shows annuity. The definition of annuity is a series of equal payments at fixed intervals for a specified number of periods. Equal amount of payment occur at each period, right? That is annuity. Basically, there are two different types of annuity: ordinary annuity and annuity due. In Korean, ordinary annuity means 보통연금. Annuity due can be interpreted as 기초지급연금. What is different between ordinary annuity and annuity due? As you can see, ordinary annuity payment occur at period 1, but annuity due payment occur at the current time, right now, right? So payment of annuity due shift left one period, like this. And there is no payment in the annuity due, right? So we usually assume ordinary annuity and annuity due is special case. In the real world, a lease contract is kind of annuity due. So if you lease a car, you should pay money right now and then pay each month regularly. At the previous part, calculating future value, we called compounding, and calculating present value, we called discounting. Annuity is the same. The solving for future value of annuity, we called compounding, and calculating present value of annuity, we call that as a discounting. This slide shows the example about the compounding of annuity. So solving for future value, 3-year ordinary annuity of $100 at 10%. So let's draw our timeline. And this is ordinary annuity. So the payment occur when? At the current time or year 1? Right, year 1. And payment occur at year 2 and year 3, right? And the compounding rate or interest rate is 10%. And let's calculate future value. At the year 3, this amount of money is the same, right? And this money goes to this, right? Compound one time. And this money compound how many times? 1 and 2 times. So sum of these 3 components, you get this number, right? And if you have a financial calculator, you can use this 4 keystroke. The N is 3 year, right? So input 3 and then push the N. And interest rate or compounding rate is 10%, so input 10. And PB is 0. What does it mean? No PB means present value is 0. Is that right? No. It means there is no cash flow. So 0 cash flow at present. The present means t equal to 0, right? And the payment is minus 100, and then compute button, and you get these numbers. Yeah, 331. As you can see, this is minus sign and this is plus sign, Yeah, it can be interpreted various way. So let's suppose, yeah, if you save this amount of money and each year, and finally you get this money. And Excel function, the FV, the rate is 10%, number of periods 3, and payment is minus 100, and present value, no present value, right? The PV is 0. There is no cash flow at the current time, right? So you input this, you get the same number, right? If n is larger than this, how can you calculate future value of ordinary annuity? So the future value of ordinary annuity, there is many n years, 0, 1, 2, n minus 1, n. This is ordinary annuity, so payment occur at period 1, period 2, n minus 1, and n. And this is a step-by-step method, so at the year n, the payment is the same, right? And year n minus 1, PMT compound one time and many terms. PMT 1 plus I. How many times compound here? N or n minus 1? N minus 1. Because during this period we cannot compound, so compound n minus 1 times. And then sum of these all the terms, you get future value of ordinary annuity, right? And write down this equation, FV PMT 1 plus I PMT 1 plus I square PMT 1 plus I n minus 1, right? How can you simplify this? Just multiply 1 plus I. This term goes to here, right? Right? And subtract these equations. And then you can erase this, right? Finally, you get only these terms. So write down this equation as this: minus IFV PMT minus PMT 1 plus I n. And rearrange this FV I PMT 1 plus I power of n minus 1. Yeah, this is the general equation. Yeah, general equation about future value of ordinary annuity, right? Here is too complex, right? But do you remember the geometric sequence, the 등비 수열의 합? Yeah, it can write down like this. sum of geometric series. So S is A plus AR n minus 1, and multiply R both sides, you get AR n minus 1 ARN, and subtract these two, 1 plus RS, and this term can be erased, right? And finally you get ARN, and S can be rearranged like this: R minus 1 ARN minus 1. So we called R as common factor, 공비. Do you remember? Yeah, we can use this equation at this ordinary annuity part. So what is common factor here? What is common factor? Common factor is here, right? 1 plus I. So FV 1 plus I minus 1, right? And what is A? And what does it mean? The A means the first term, right? The first term is payment, right? So payment 1 plus I n minus 1, right? So rearrange this equation, you get I PMT 1 plus I n minus 1, right? Yeah, it is the same with this. Ooh. Yeah, same with this. So if you have a problem about the future value of ordinary annuity, you can use this general equation, right? Okay, here is another example, the solving for present value. So we have 3-year ordinary annuity of $100 at 10%. So let's draw a timeline. 0, 1, 2, 3. And there is payment here, right? And we want to know present value. So the payment at year 1, it discounts one time, right? And year 2, it discounts how many times? 2 times. And year 3, it should be discount 1, 2, 3 times. And sum of these 3, you can get present value, right? If you have a financial calculator, you can also use 4 keystroke. The N is 3, right? And interest per year is 10%, so input 10. And payment is 100. And FV is what? In this case, 0. There is no FV. What does it mean? This means there is no additional cash flow at the end of timeline. Yeah, except payment. You can also use Excel. The function is PV, right? PV, the rate is 10%, so 0.1 or 10%. The number of periods 3, the payment is 100, the FV is 0, and you can get this number. So far we deal with ordinary annuity, but now we deal with annuity due. So 100 payments occur at the beginning of each period. So let's draw a timeline. 0, 1, 2, 3. Payment occur at the current time, right? And there is no payments at the last period. So now we want to calculate future value. So compound this payment with compounding interest, right? Yeah, and sum of this, the future value of annuity due. Compared with ordinary annuity, which one has a larger value? Yeah, annuity due, because 1 plus I, this term is more than ordinary annuity. So if you simply calculate annuity due with general function of ordinary annuity, multiply 1 plus I, and then get this number. If you have a financial calculator, you can also calculate annuity due. The alternatively set calculator to begin mode and solve for the future value of annuity due. So in this case, you firstly input the second and then set and then push begin button, and then you can show on the display the letter begin. Yeah, that is the begin mode. So input 4 keystroke and then push the FV, you can get the number on this display. In Excel, and there's one more thing different. There's a type. The type is 1. Usually type is default number is 0. It means ordinary annuity. So as a previous example, we just erase these numbers, right? So every function automatically identify this is ordinary annuity. But in this case, we want to calculate annuity due, so we should type 1. That means annuity due, right? This slide shows the present value of annuity due. As I mentioned before, annuity due 1 plus I get this much variable than ordinary annuity. So as I wrote before, FV ordinary annuity multiply 1 plus I is future value of annuity due. In this case, present value of annuity due can be calculated by present value of ordinary annuity multiply 1 plus I. Yeah. So get this much variable than ordinary annuity. And when you use financial calculator, you should set the begin mode and solve for the present value of annuity due. Set to the begin, okay? And if you use Excel, and as I mentioned before, just change to type 1. So input type 1, this function identify this as annuity due, so they automatically generate the numbers. After setting begin mode, financial calculator still identified annuity due. So if you want to calculate ordinary annuity after serving annuity due, you should set back to end mode. So the second, and then set and begin. Yeah, this letter can be erased. What if it was 10-year annuity or 25-year annuity or of perpetuity? The present value of perpetuity, how can it calculate? The perpetuity means the cash flow occur forever. So the payments occur forever. So n is infinite number. So how can it calculate? From the present value of ordinary annuity function. Present value of ordinary annuity can be calculated by using general formula, right? The PMT over I 1 minus 1 over 1 plus I power of n, like this. In this case, n goes to infinite. How can you calculate? Do you remember at the high school? Yeah, take a limit. Maybe this is the number, so we can write down at this and take a limit here. And then this term, when it goes to infinite, this can be goes to 0. So finally we get only this term. So I can write down as this. Present value of perpetuity is PMT over I. And it can be used when we calculate preferred stock in US. Preferred stock in US, they pay fixed dividend and no maturity. So we can calculate as this. PMT can be changed by dividend and over I. Yeah, that is one application. This is another example. Mike just turned 20 years old and he wants to save $3 a day for his retirement. Every day he places $3 in a drawer. At the end of each year, he invests the accumulated money. It is $1,095 in a saving account with an annual return of 12%. It's a long explanation, so we can easily understand by drawing a timeline. So drawing timeline, the 0 he born, 20 years old, 21, and 64 and 65, and he accumulates this amount of money to the bank, right? How can he calculate future value? Yeah, this money is this, right? And this money can be have this amount of money. He compound 1 year, right? And go on this and this. Right? Yeah, this is 44, not 45. And how can you calculate this? Using annuity formula. So FV annuity can be calculated by PMT over I, 1 plus I over N, not over, power of N minus 1. So input the numbers. Yeah, this is 45 because there are 45 terms. Yeah. You can also use financial calculator or using Excel. So, for example, the PMT minus 1095 and equal to 45, PV 0, I per year is 12, right? 12%. And serving for what? FV. Yeah, that is financial calculator method. Or you can use Excel. In the Excel, the FV function and input the numbers, right? For example, 0.12, that is rate, number of period, and payment. And yeah, there is no money when he was born, so the current cash flow is 0, right? We can have another application. So when the palm grow at some rate, when the palm goes bigger and bigger, the dividend grows at some rate. So we can use this when you calculate the stock valuation part. This is the second question. His 7-year-old friend Bill starts saving when he becomes 40 years old. How much will Bill have when he turns 65 years old? In the timeline, the Bill starts 40, right? So the only change variable is this, n. So n goes to 25, right? So when you change this variable, you can get the number. The rest question, how much Bill deposit annually to catch the mic when they become 6 years old? The rest of the timeline, 0, and Mike starts saving at this year, and Bill want to save when he is 40 years old, and he want to catch the mic. We already calculate Mike's money when he turns to 65 years old from this equation. You can get the numbers. This amount of money he will get. So from the equation, we don't know the PMT, but we know the I, the 12%, right? And 1 plus I, so 1.12, and the N is 25 years, right? And minus 1, and solving for PMT, that is the answer of this question. And you can also use Excel function. the PMT, the rate is 0.12, number of period is 25, and the PV is 0, right? He don't have money now, but he want to catch the market money, so that is FV here. And then you get the number, the minus 11154.42. Yeah, he saved this amount of money annually. He can catch the mic when he becomes 65 years old. That is the answer of this question. This slide shows when you have uneven cash flow, how to calculate the present value. Yeah, it is simple to calculate separately. So the cash flow at T1, 100, you can calculate as this: 100 over 1 plus interest rate, right? Just discount one time. And cash flow in T2, discount 2 times, right? And cash flow at T3, discount 3 times. And cash flow at T4, there's a negative number, but you can discount, right? And some of these numbers, yeah, that is the present value. You can also use this example when you calculate irregular dividend company. At the perm stage is very begin, they can give irregular dividend. But after some time, perm size goes up, they can give fixed dividend. So in the early stage, we can calculate the perm value using this. I will explain more detail later.